Okay. Sorry. Ayaw mag-share ng video nung account ko dun sa phone. Kaya nagtagal ako. Kailangan ko palang i-restart yung ano natin. Ayan. Okay. Sorry about that. Okay. So before we proceed to our discussion, so meron akong mga nag-check kasi ako ng papers ninyo. And merong mga hindi nakapag-test or nakapag-submit. So nagpaalam na ako. Lahat ng hindi makakapag-test mula quiz 1 hanggang quiz 6, bibigyan ko na lang sila ng isang special exam. Okay, so pumayag naman yung chairperson namin. Kasi, you know what, it's a hassle na every time na magkakaroon ng problema sa isang quiz, gagawa ako ng separate. So para hindi na lang ganon, if you miss one quiz, you will take a special exam. So that special exam will cover everything. So I'll give it at the end of finals. It's just a special exam. Okay. Again, and then on Monday, balita ko wala tayong pasok. Nag-email yung HR sa amin. Holiday daw sa Monday. Akala ko hindi na matutuloy yon kasi online naman. At parang tuloy ba ang fiesta? Hindi, joke lang. Di ba fiesta sa Sunday sa Angeles? Sa tradition na after fiesta, walang pasok. Okay. It so happened. Ayan, nakala ko hindi natuloy yun. So, ngayon tuloy pala. So, walang pasok doon sa Monday. It's a holiday. Ayan. So, that will give you time to finish all your activities. Marami pa hindi nagpapas ng mga activity. No? Ako kaya hindi ako nag-check ng mga uncompleted. Gusto ko kasi mag-check ako complete na. Okay, so sino pa hinihintay natin? Ayan. Okay, ang lesson natin ito ay actually, feeling ko alam niyo na to. Dahil ang mga sa electronics ginagamit nila lagi ito. Tama ba? Sa elec dev ninyo, ito yung method na ginagamit. Yung Thevenin's Theorem. Kasi, okay. Sige, Jedron, thank you. Okay, so let's proceed. Or, okay, let's have one more minute. Sorry, nagkaano yung phone ko, hindi ko naayos agad yung video kanina. Okay, so let's discuss Thevenin's theorem. Okay, class, ang Thevenin's theorem, actually ka-counterpart niya yung susunod, yung discussion natin for next week, yung Norton. But we'll start with the Thevenin's theorem. If you're familiar with, if you can remember, ano kasi yun? Yung source transformation natin. So this is related to Thevenin's theorem. Okay. Okay, so what is this theorem all about? Teka, mag-record muna pala ako. Ayan. Okay, so this states that two linear circuit can be replaced by an equivalent two-terminal, that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source that is VTH, that's the equivalent voltage, in series with an RTH, that's a equivalent resistance, where VTH is the open circuit voltage at the terminals and RTH is the input or equivalent resistance at the terminals when the independent sources are turned off. Yun. Intindihan niyo ba yung ibig sabihin nun? Okay, so ang ibig sabihin nun, if we have a network, let's say this is a network. Kuha ko ng circuit. Okay, so example, I have a network of electrical components. Ayan, so let's say that is the load R. Ayan. Nakikita nyo ba? Ayan. So let's say, okay. So let's say I have this network. It's a two-mer, yung dun sa figure natin. So let's say this is A and this is B. And then a current will flow through this branch going to R. Okay? So that means, since this is a network, at ito lang gusto nating kunin. So let's say we want to find the voltage across here. Okay? Ngayon, based dito, ito ang sinasabi niyang, this part is yung sinasabi niyang linear two-terminal circuit. At itong part na to, this whole part, ang buong part na to ng circuit, ayan, pwede natin niyang gawing equivalent Thevenin's circuit na meron tayong voltage, okay, na meron siyang nakaseries na resistance na tatawagin nating VTH at yung resistance is RTH. Ayan. Itong buong to can be represented by these two elements, a voltage source and a resistor. Tapos, pwede na nating idikit ulit yung R dito. Ayan. Para makuha natin yung value ng V. Para makuha natin yung value ng V, masolve natin, we will just use probably a voltage divider or a series circuit. So, ang gagawin lang natin, this one we can be written in an equivalent circuit as a simple voltage in series with a resistor. Okay. Ayan. Yun yung gagawin lang natin. Okay, sa ECE, lagi itong ginagamit lalo na sa electronics. Okay, mga Thevenin's equivalent circuit. Ayan. Now, to solve for I, the current on the load, so gumamit lang siya ng voltage Ohm's law that is in series kasi pinag-add yung equivalent resistance at saka yung load resistance natin over divided from the voltage equivalent, Thevenin's equivalent voltage. And or para makuha yung voltage ng load using voltage divider. So this one. Okay. Okay. So meron tayong cases dito na susundan. Yan. Iba-ibang cases. So case number 1, the network has no dependent source. So yung pinakamadali. Now to find RTH, turn off all independent sources and remove the load at terminal AB. And then solve for RTH using series and parallel resistances. Okay? Okay, class. Yung step 1, ang sinasabi sa step 1 na turn off all independent sources and remove the load. Okay? So, ang gagawin natin dito, tatanggalin muna natin ito. Yan, tatanggalin natin ito. And then we will remove the independent sources. Okay, class. Yung pag-remove, sabihin tatanggalin natin sila. Pag voltage source siya, isi-short natin. Okay? Pag current source naman, i-open. Yung ibig yung sabihin, open natin. Pag voltage source, isi-short. Pag current source, i-open. So, yung ibig sabihin yung turn off. Next. Then, solve for RTH. Okay? So, that means pag sinort natin yung mga voltage sources at in-open natin yung mga current sources, para maglalagay tayo ng ohmmeter dito para makuha natin yung equivalent resistance. So, di ba mawawala ito? So, magko-compute ka, ano yung resistance across AB. Yun yung magiging value ng RTH natin. So, you just use series and parallel resistances or sometimes, nagiging silang Y delta transformation. So, it's up to you on how you will get the equivalent resistance. Okay, that is finding for the equivalent resistance. Now, let's get the equivalent voltage. The equivalent voltage is, again, we will remove this and then we will solve for VH using any method of analysis. Parang kukuha lang tayo ng voltage across AB. Tanggalin natin, pero kung maglalagay tayo ng voltmeter dito, ano yung magiging reading ng voltmeter? Or if it's not like that, we can solve what is the voltage across terminals AB. So, mostly, syempre, dahil paborito ko ang mesh analysis, we will use mesh analysis or KVL. KVL lang. Okay, probably we'll go with case number 1 muna. Mamaya na yung case number 2. Ayan. Case number 1. Okay, so let's have an example. Okay, so we are given this circuit. We are to find the Thevenin equivalent circuit of the circuit shown below to the left of the terminals. Then find the current through 6 ohms. So I think that's the symbol of a potentiometer. It's a varying resistance. But on the second part of our problem, we are to find the current flowing through it if it is set at 6 ohms. Okay, but first we need to find the Thevenin's equivalent resistance. Okay. So, ang gagawin ko ay tatanggalin ko muna yung mamaya na nga lang. Drawing ko na muna. Okay, so what I'm gonna do is first, I will remove this. Okay, now let's have this is for RTH. So let's remove this one. Ayan, i-remove natin yan. So we'll have Ayan. So we are to find the resistance across AB. In order to do that, we will remove the voltage at the sources. So that means if is, ay, so 1 ohm pala to. If this is a voltage source, so therefore this will be shorted. Ayan. Okay. If this is a current source, so this should be open. Tatanggalin natin to. Okay, so what is left is ganito. Ayan. Okay, and then we need to get the, okay, if we will have an ohmmeter, what should be the measurement of the resistance across AB? Ayan. So, pwede naman natin siyang isolve. So, halimbawa yan, that means these two are in parallel. So, yung 4 ohms parallel to 12, so that's equal to, lang calculate. It's 3 ohms. And then it's in series with 1 ohm. So therefore, RTH is equal to 4 ohms. So RTH is 4 ohms. Okay. So next one is we are to find the VTH. So to get VTH, you'll return the sources. Go back to the drawing. And then we are to find what is the voltage across this. Yeah, so what's the voltage across terminal A and B? Okay, so you can use any method of analysis. Pero ako syempre, I'll be using syempre mesh analysis. Okay, so let's have this as I1, I2. So based dito, I can conclude that I2 is equal to negative 2 amperes. Tama ba? Negative 2 amperes. Okay, now let's have the KVL at I1. So we'll have negative 32 plus 4 I1 plus 12 times I1 plus 2 is equal to 0. Okay, so what should I have? I'll have 4I1 plus 12I1 plus 24 minus 32 is equal to 0. So I'll have 16I1 is equal to 8. Okay, divided by 16. So I1 is equal to 0.5 amperes. Ayan. Okay, so 0.5 amperes. Okay, so this is 0.5 amperes. Ayan, class. So what should we do now to get VTH? Okay, hindi naman tayo pwede mag-KVL dito because this is a source voltage. I mean a current source. So mag-KVL na lang tayo sa pinakalabas. Okay, so let's have the KVL. 1. So KVL natin is dito. Okay, mga nabili kong marker. So, sa pinakalabas, or pwede naman sa 12, kung gusto niyo sa 12, pero sa labas na lang. Ay, hindi sila sumusulat. Ano ba naman yan? Yun. Ano ba to? Ayun, KVL doon. So that will be negative 32 plus 4I1. Okay, class, there's no current here, so just neglect that. Wala namang kasing current doon. Plus VTH is equal to 0. So that's negative 32 plus 4 times 0.5 plus VTH is equal to 0. So what's VTH? So VTH is 32 minus 4 times 0.5. 30. 30 volts. Ayan. Okay, so therefore, the equivalent circuit is $30 and 4 ohms. Ayan. So this is the answer. Ah. Okay, any question? Any question on our equivalent circuit? Wala. So this is our answer on the first part. So what's the equivalent circuit? So ito siya. Okay. Now, let's connect now the equivalent circuit to our RL. RL natin. RL. So it means that this whole part of the network is equivalent to this one. So we can have 30 volts, 4 ohms, and then you connect the RL. Ayan. Okay. If RL is equal to 6 ohms, what is IL? Okay, so yung I total natin is equal siya sa 30 over 4 plus 6, which is 3 amperes. And I total is equal to IL because they are in series. So therefore, IL is equal to 3 amperes. Ayan. Okay, any question? Ito ba? Dito ba? Dito? Kasi hindi siya closed loop. Talagang walang current na dadaan dito sa part na to. Okay, magkakaroon tayo ng voltage. Kaya lang wala rin namang effect yung voltage. Kaya walang current kasi open circuit siya, hindi siya closed circuit. So that's why walang current talaga. Nasa problem natin. Ayan. Sa second statement. If RL is 6 ohms, so what should be the current? Yes. Okay? Kaya kung titingnan niyo pati dun sa KVL natin, 'di ba KVL natin doon para makuha ito. Actually, pwede naman sana siya dito. But it so happen na mahirap kunin itong volt kasi current source siya. So, ginawa ko sa pinakadulo na lang. Pero pwede naman din siya sa 12. Kung sa 12 natin siya kukunin, ano yung current through 12? Diba? It should be I1 minus I2. So, yung magiging current sa 12, dito. Kaya, pwede naman dito mo siya kunin. Wala pa rin magiging current dito sa 1 ohm kasi open circuit pa rin naman siya. Magkakaroon ng effect yung ganito kung kung instead na 1 ohm yan, let's say 1 volt yan, pwede i-add natin siya kung voltage yan. Kaya lang din naman siya voltage, walang current, so wala siyang magiging voltage drop dito. Kasi it's an open circuit on that part. Okay. Okay, so let's proceed. Kung wala na yung question, let's proceed to another one. Okay, yung number 3 na lang muna. Okay, kasi yeah. Okay. So let's have number 3. So the given is ayan. Okay, using Thevenin's theorem to obtain the Thevenin's equivalent circuit to the left of the terminals, then solve I. It's the same. Okay, so it's the same as the first example. Ayan. So what is the value of I? Okay, using Thevenin's theorem. Okay, so same lang. Una, kunin na muna natin yung RTH. Okay, kung RTH yan, kunin natin ng RTH. Tatanggalin muna natin ito. Okay, at the same time, tatanggalin na rin natin yung mga sources. Para makita na natin agad. So since ito ay isang voltage source, yan ay magiging shorted. So we'll have 6 ohms. Since ito ay 3 ampere, so yan ay magiging open. Then we'll have 6 ohms. We'll have 4 ohms. And then, nandito yung A at saka yung B. Okay, now what is the resistance across AB? So if you will add this, so these are in series, so therefore that will be 12 ohms. And then, yung combination nila, nakaparallel siya sa 4. Parallel sa 4 ohms. So therefore, RTH is 3 ba? Tama. 3 ohms. Yan. Okay. Next. Now for VTH, okay, so we still remove that. Kaya lang babalik na natin yung mga sources. Okay, ano ang VTH, which is across AB? Okay, class, kung titingnan natin, ayan, kung maglalagay tayo ng voltmeter dito, di ba parang yung measure niya kung ano yung voltage dito sa 4 ohms. Kaya kung makuha natin kung ano yung voltage doon sa 4 ohms, yun na yung ating VTH. So kahit hindi na tayo mag-KVL kahit saan, since pwede naman natin makuha yung voltage dito, so pwede na natin kunin yun as voltage. Okay? So anong method yung gagamitin natin? Method ay, syempre, pwedeng source transformation kung gusto ninyo dahil series itong sa voltmeter. Pwede yung source transformation. Madali ba siya doon? Oo, pwede. So, sa tingin nyo, anong susubukan natin? Anong method? Wala. Ako na mag-decide. Para maiba naman, mag-source transformation tayo. Okay, so using source transformation, so this will become 6 ohms. 3 amperes, 6 ohms, 4 ohms, B and A. Okay, class. Multiply natin itong dalawa. Hindi pala divide. 3. Okay, 3 amperes. Ayan. Kung 3 amperes yan, going upward, so pwede nating i-add yung dalawa. So magiging 6 amperes. Ito ay 6 ohms. 6 ohms. 4 ohms. A and B. Tama ba? Pinag-add ko to, magiging 6, yung 6, yung 6, tapos 4. And then, i-transform natin ulit ito ng voltage source. Yan. So, ito ay magiging 6 times 6, 36 volts. So, ito 6 ohms, then 6 ohms. Then, 4 ohms. Ayan, pwede na. So, I total is equal to 36 over 16. 16. That's equal to 2.25 ampere. So therefore, the voltage at 4 ohms is 4 times 2.25. So that's equal to 9 volts. So therefore, we can conclude that VTH is also equal to 9 volts. Okay, question? Ayan. So, magiging sagot natin ay, therefore, the equivalent circuit is 9 volts. Yung resistance natin, 3 ohms. Ayan. So, yan yung ating Thevenin's equivalent circuit. Okay? So, pag in-add down natin yung pag in-add natin yung, ibalik natin, ano pala eh, ayan, 1 ohm. Ano ang magiging value ng I? Yan. So therefore, I is equal to 9 over 3 plus 1. So that's equal to 2.25 amperes. So this is the answer. 2.25 amperes. Okay, any question? Okay, so let's have another example. Example number 3. Ayan. Okay, using Thevenin's equivalent circuit, find the value of I. Okay, so find the value of I using Thevenin's equivalent circuit. Okay. So, ang gagawin niyan natin, ang terminal AB natin ay nandito. Ayan. Okay, so A, B. So, ang gagawin ko, pwede bang iikot kong ganyan? No? I-redraw ko lang. Para mas malinaw lang naman siya. Para na madali siyang intindihin. Okay, so nandito yung yung 13 ohms. Ayan. Okay, so nandito yung A at nandito yung B. Okay? Now, let's have the R. Okay, so R equivalent muna tayo. R equivalent. Ay, ano ba to? 3 ohms. So, this will be shorted. So, still have 3 ohms. And this is opened. And this is 2 ohms. And this is shorted. Ayan. So, therefore, RTH is equal to 3 parallel to 2. Okay, so it's 1.2 ohms. So RTH is 1.2 ohms. Okay, so ito ay nakaparallel yung 3 sa 2. So that's 1.2 ohms. Okay, next. So let's have the TH pala to. So VTH, so we'll return them kaya tatanggalin natin 'yun. Ayan. So, kailangan natin makuha anong value ng VTH doon. Ayan. Okay, so, method yung madali. Kung kaya natin kunin yung voltage dito, okay, sandali ulit. So, what's method? Source transformation ulit. Or KCK or mesh analysis na lang. O sige. Source transformation daw tayo ulit. Okay, so kung source transformation, kaya naman siya, di ba? Kasi series ito dito. So kaya naman. Kung magso-source transformation tayo, so ito ay magiging ganyan. So 12 divided by 3, so that's 4 amperes. So this is 3 ohms. Ay, sorry, mali. So this should be 4 amperes. Parallel pala. 3 ohms. And this is... Ay. Ano ba naman yan? 5 amperes. That's going downward. Ayan. And then we'll have 2 ohms. Plus minus 7. Ayan. Volts. Okay, and then we can add this too. So, since mas malaki yung pababa, so magiging 1 ampere, 3 ohms, ay, 2 ohms. Ayan, 7 volts. Okay. Wag nating ayoko siyang i-parallel. Pero pwede din naman. No? This one? Ito? Ayan, yan ba? Clarence? I think you can view my video. Sige. Ayan. And then, tanggalin ko na lang ito. Sayang kasi yung papel. Ayan. Next is, pwede naman i-parallel ninyo or pwede naman source transformation nyo ulit. Kaya lang ito ay magiging negative positive. So this is 3 volts. Multiply yung dalawa. Then I'll have 3 ohms and 2 ohms. 7 volts. Then we can just get I total. So I total will be 3 over 5. So that is 0.6. Ayan, 0.6. Kaya lang, the direction of the current is in this direction. Ayan. So that is equal to 0.6 amperes. So therefore, V across 2 ohms is equal to 2 times 0.6 or 1.2 volts. Ayan. So 1.2 volts. But since nandito yan, so therefore ito ay negative, ito ay positive. Kasi current is in this direction. Okay, because of this one. Ayan. Okay? So therefore, how will we get VTH? Okay, since ganyan yan, dito na lang tayo mag PKVL. So kung itong plus minus ng VTH, ayan, so therefore, we'll have 7 plus 1.2 plus VTH. So VTH is equal to negative 8.2 volts. (8.2 volts). Negative 8.2 volts. Ibig sabihin baliktad, no? Ayan. If that's the case, what will be our equivalent resistance? So our equivalent resistance will be, so ibig sabihin baliktad dito, so plus minus. Yeah, so this is 8.2 volts. This is, what's our 1.2 ohms. And this is our 13 ohms. Now to get the value of I, so I is equal to, kaya negative siya baliktad. So negative 8.2 over 1.2 plus 13. So what's the value of I? Negative 0.58. 0.58 amperes. Ayan. 0.58 amperes. Okay, so that is our last example for those with purely dependent sources. So on Friday, we will have naman KVL equivalent circuit naman with ano kasi without with dependent sources. So sa Friday, dependent sources naman ang meron tayo. So this time kasi puro sila independent sources. Okay? Hindi naman, Noel. Hindi naman. Nakadepende lang kasi siya dun sa direction o dun sa polarity. O, nasa problem kasi yung direction eh. It so happen lang na baliktad. Baliktad yung naging result. Basta naging consistent ka lang, wala namang problema. Yung hindi pa balik ba? First page. Ito ba siya? Ayan. Okay. So that's it for today. See you on Friday.